this session we will see how to create and test our model. So now the most important step is to create the model architecture. So here you can see that we are defining that model architecture. Here I have taken a convolution 2D function with filter size as a 64, kernel size as 3 by 3. We have to pass the input shape and the activation function to be relu and the padding as same. Similarly, you can take any number of filters, any kernel size and the activation function, and you can change the padding also. Doing this is known as hyperparameter tuning. So here we have also placed some layers like max pool 2D whose pool size will be 2 by 2, and we have added a dropout layer also. Similarly, again adding a convolution 2D, max pooling 2D function and a dropout layer, and after finishing this we will apply a flat layer to flatten the data and pass it to the bench layer. I have applied a dropout layer, after that a dense layer as the final layer, as you can see here. It's been always contain the number of neurons as the total number of classes, which are 43 here. As it is a multi-class classification problem, we will use the activation function as a softmax, because the softmax works as a multi-class classification and gives a probability of all these classes. So let's run this command and make this architecture. Let's move forward. We have created the architecture here. The next step would be to compile this one. So in compiling, I have used losses sparse categorical cross entropy. And so the loss here is a sparse categorical, because if you use categorical cross entropy, it will not work. As the data is sparse, it contains 43 classes, which is very diverse data. So we will use the losses sparse categorical. We have used the optimizer as Adam and accuracy as the matrix. We will print out the summary of this model. So let's see here the summary of the model. As you can see, all the layers with their param, all the layers are there with their params. We have added convolution 2D layer, match pool 2D layer, dropout, flatten, dense layer, and so on. And the last layer is of 43 neurons, because it is the final layer. So here you can see that the total number of params are 1, 0, 3, 5, 6 to 7, and all these are trainable. So the next step would be to fit this model. So in order to fit this model, we will call fit command and pass over the data. So here the data will be X train, Y train. The epochs will be 10, the batch size is 128, and the validation data as X validation and Y validation. So as here the number of epochs are 10, it will take some time to run. We have already split that data for validation. So we are passing the validation data here, as well as to print the outputs of how much the machine is learning on each epoch. It will take some time because I am running it on 10 epochs. So we will run this command and start the training of the machine. So as you can see here, the model is getting trained. It's currently running on the first epoch, and it will take time because CNN generally takes time. The execution time of this command will be depending upon your computational power, how much the computational power your collab is having. Like if you have high computational power, then you can run this very easily in a very short time. You can run this either using a GPUs or TPUs. Also, you can select GPUs and TPUs in Google Colab. So for that, we need to go to edit section, there notebook settings. So here you can select your hardware accelerator as either GPU or TPU. So now let's fit the model and see what is the accuracy of this model on each epoch. So it took around more than half an hour for this model to get trained on 10 epochs. And you can see that the accuracy for the training data is around 0.89, that is 0.9 to 1, and the validation accuracy is around 0.99. So you can increase the number of epochs as much as you want if it supports your computation power. So now let's see how to create the plotting of accuracy and the loss. So here what I have done is I have taken the model history and stored it in data frames. And from this data frame, I am creating a plot of accuracy and validation accuracy. Similarly, a plot of loss and the validation loss. This is really easy method to plot. It doesn't require any visualization library. The plot function is already predefined in the data frames. Let's see the plot here. So here you can see that the blue line is the accuracy for training the data, and the orange line is the validation data or the validation accuracy, which shows a high gap, which shows that the model is highly overrated. You can hypertune this model in order to reduce this overfitting, putting some of the techniques that you can apply and polarization of type 1 and type 2. Or you can also drop out. Or you can also apply dropouts. You can see the change in this model according to your own requirements. You can change the number of layers, the number of kernels, and so on. Similarly, here you can see that the loss is decreasing, and for both the training and validation data, the loss is getting decreasing.